You ever wonder how scientists really figure out what makes us tick? How they go from just a simple question about everyday life to some huge, groundbreaking discovery? Well, today, we're not just going to talk about it. We're going to build a psychology experiment right from scratch, step by step. Okay, let's kick things off with a question that I'm betting we've all asked ourselves, probably at 2 in the morning with a textbook staring back at us. Does pulling an all-nighter to cram for a big exam actually help, or does it just completely tank your score? This is like the perfect question to get us started. All right, so before we can even think about testing anything, we need a blueprint. Seriously, it's just like an architect designing a building. We've got to have a super solid plan to make sure our whole experiment is strong enough to give us a clear, trustworthy answer. So every good experiment really starts by setting up two opposing ideas. Think of it like this. First, you've got the null hypothesis. That's kind of the default assumption, right? It's the idea that there's no connection at all. Then, on the other side, you have our alternative hypothesis. Now, this is our actual prediction that, yeah, sleep deprivation really does mess with test scores. Our entire experiment is basically designed to see if we can find enough evidence to knock down that first idea, to prove that nothing's happening is wrong. Okay, so how do we actually test this? Well, the key is we have to change one thing on purpose. That one thing is what we call the independent variable, or the IV for short. You can think of it as the cause in a cause and effect relationship. So for our sleep study, the IV is super simple. It's the amount of sleep we let people get. And if the independent variable is our cause, then it makes sense that the dependent variable, the DV, is the effect we measure. It's the thing we're watching to see if our change made any difference. In our experiment, that's going to be the score each person gets on the test. See the link? We're looking to see if changing the sleep, the IV, causes a change in the test scores, the DV. Okay, so we've got our blueprint, but a plan is pretty useless without the right building materials, right? In psychology, our materials are people. So who are we going to test this on? This is a huge deal. Choosing the right participants is an absolutely critical step that can literally make or break the entire study. And what's so interesting here is that there's no single perfect way to find people for a study. I mean, look at this. Random sampling, that's the gold standard. It's the best way to be unbiased, but man, it can be really, really hard to pull off. Then you have volunteer sampling, which is super easy, but you risk getting a group of people who aren't really representative. And stratified sampling is awesome for making sure you get all the key groups, but it's pretty complex to set up. It really shows that every choice is a trade-off, You're always balancing one thing against another. All right, we've got our plan. We know who we're looking for. Now it's time for the main event, running the actual test. This is the fun part. This is where we decide where and how we're going to see our hypothesis play out in the real world. And right away, we have a big choice to make. Do we bring everybody into a perfectly controlled lab that gives us tons of control over, noise, distractions, everything? But the downside is it's not real life. It's artificial. Or do we do this thing in a more natural setting, like an actual dorm room? That feels way more realistic, what scientists call high ecological validity, but we lose a ton of control over what's going on. It's the classic scientific dilemma, really, control versus realism. Okay, let's say we go with the lab for maximum control. Here's how a pretty standard experiment would go down. First, you gather your participants. Then, and this part is so important, you randomly put them into one of two groups. You've got your full sleep group and your no sleep group. The next day, everybody takes the exact same test under the exact same conditions. And finally, you just compare the average test scores between the two groups. Was there a real difference? That simple but really powerful design is how we get our answer. Now, before we even peek at our results, we have to talk about something that is the absolute bedrock of all science: ethics. There's a really strict code of conduct here, and it's all about protecting every single person who participates in a study. It's non-negotiable. The whole thing is built on a foundation of trust and just basic respect for the people who make this research even possible. Rule number 1, the most fundamental of all, is informed consent. What this means is, before anyone agrees to do anything, they have to know exactly what the study is about, what's going to be asked of them, and any potential risks involved. It's all about total transparency. No surprises. Beyond that, the researchers' number one job, their top priority, is to protect participants from any kind of harm, whether that's physical or psychological. So in our sleep study, for instance, we'd have to think really carefully about the effects of sleep deprivation and make sure we aren't putting anyone at any kind of risk. And this is so important because it flips the power dynamic. The participants are the ones in control. They have the absolute right to walk away from the study at any time for any reason with no questions asked. Participation is always, always voluntary, period. And finally, this all comes down to a promise of confidentiality. Any information you collect has to be kept private and anonymous. A participant's identity should never, ever be linked to their results. This is what builds the trust that you need to do honest, meaningful science. Okay, so we've run our experiment ethically, and we've got our results. Let's say the no-sleep group did worse on the test. Awesome, we're done, right? Well, not so fast. Now comes maybe the most important question of all. Can we actually trust this finding? See, for our results to be truly trustworthy, they need to stand on two pillars. The first one is reliability. That's just consistency. If we did our study all over again, would we get pretty much the same results? Then the second pillar is validity. This one's about accuracy. Are we actually measuring what we think we're measuring? Is our test really about academic performance, or is it just measuring how tired someone is? For our findings to mean anything at all, they have to be both reliable and valid. So what's the big takeaway from all this? I think it's that every single step in a psychology study, from coming up with a hypothesis, to picking people, to controlling the variables, to following all the ethical rules, every single step is a careful, deliberate choice. It's like this systematic journey that's designed to cut through all the noise and randomness of human behavior to find an answer you can actually hang your hat on. And that kind of leaves us with one last thought to chew on. We just walked through all the incredible detail it takes to answer one seemingly simple question. It really makes you wonder, doesn't it? If this is what it takes for one study, how many thousands of these studies, each one like a single tiny piece of a giant puzzle, does it take to even begin to build a true understanding of the human mind?